My name is this too loud? It's good, okay. It's reverberating in my ear. So, my name is Nick Bicanic. The title of this talk is Blinq, and you'll miss it. You'll figure out why in a minute. It's called Blinq. And I am a serial entrepreneur, but I've mostly, thus far in my life, focused on software. In fact, I've pretty much exclusively focused on software. So this is a story about ideas and how to execute them, but it's also a story about what happens when you try and apply software processes to a piece of hardware. So first of all, who am I? Well, we didn't do the intro, so I'll do it really quickly. My background is in software, although I dabble and do a bunch of different things at the same time. I've known some of you for a number of years. I've known Anjay for a number of years. Anjay is actually one of the organizers of Bit0spiration. I'm very grateful to have been invited here multiple times. Anjay invested in one of my companies. So I do software, I tell stories in various different media. I've made movies. In fact, I'm on my way to Nigeria to shoot a second part of a movie about Boko Haram. But as far as ideas go, I'm a serial entrepreneur, and like I'm sure many of you, not just in this room but in the entire conference, you get ideas from various different things, but mostly when you're trying to solve a problem. For example, I encounter things every day that I think are broken and don't work very well. Here's a typical example from today, this pointer. It's really annoying because if I hold it in my hand, I can very easily accidentally hit the advance button. So it's the kind of thing that makes my mind wander and makes me go, well, I could just build a much better pointer it would naturally hold in my hand. Now, 99% of the time, those ideas are discarded because I'm really not that interested in making pointers. But I'm just trying to tell you that even though I normally think about software, it's not unusual for me to encounter in my daily life things that I go, this is crap and I want to make it better. So sometimes making the world better involves creating a different kind of well that a village might more efficiently extract water from the ground from. Sometimes it involves creating a photo sharing app with funky filters. I would ironically hope that it would be more of the former than the latter, but sadly, many of us, myself included, tend to focus on the things that are in our immediate surroundings. So we make photo sharing and social networking more efficient, which is, while it can be lucrative, is also doesn't really make the world a much better place. So, what's this talk about? Well, we already did that, so I'll just skip to the next slide because there's a fair amount to go through. Ideas are usually based on problems. Already talked about that. This is a quick summary of how software works. Most people know this, so I'll zip through it. You have an idea, you build an MVP. An MVP contains aspects of architecture, front-end, back-end, data structures, UX, and design. What does that mean? Well, if you've done software often enough, you kind of do these steps automatically. So, I'll go, look, the way in which trucks moved cement around on a production site or multiple different production sites is inefficient. So how do we plan where the trucks are? Well, we put GPS systems into the trucks, then we have a system which coordinates which truck goes where, when, and you automatically start thinking in your head, how do you onboard people? How do they register? What method of location do you use? How do the databases look to make this work? So obviously, there's other cycles to software development. There's investment, there's distribution and marketing. The blue things that are on this slide we will not talk about today, but we will in a second talk at some point, assuming I get invited back again, because hardware investment and hardware distribution and marketing are quite different to software. But so for the purpose of an app, which I have a lot of experience in, the first two steps, the black ones, are very straightforward. You have an idea, you quickly pull together a prototype using some sort of sketching tools. Maybe you do it in iOS, maybe you do it in Objective-C, maybe you use Swift to make an iPhone app, maybe you use Java, and you have a simple prototype that you can show to investors. So what happens when somebody tries to do that for a piece of hardware? Well, before we jump into that, this very famous young man, well, not that young anymore, but still famous, once said that software is eating the world. It's interesting because a lot of people assume this statement to be true simply because they wander around and they look at how many different industries software has disrupted, and they just go, well, you apply software to something, thousands of jobs get lost, the world becomes more efficient, new opportunities are created, therefore it's always good. While that point is somewhat debatable in the longer terms of geoeconomic health, the interesting point here is that software doesn't actually translate to hardware all that well, because when you build hardware, there's about 1,000 more ways to die. So, talk about hardware now. Remember those phases that we had? We have the idea phase and the MVP phase. Well, the idea phase is still the same. When you have an idea for a piece of hardware, you wander around the world just like I did with a laser pointer and you go, I'm going to build a better laser pointer. However, the steps that you go through no longer include the databases and just the UX. They suddenly include three key things. Sorry, there's bold and highlights missing on this slide, but just work with me. Electrical engineering, mechanical engineering, and industrial design. Electrical engineering refers to how things work inside. So for example, in the case of this laser pointer, the electrical engineering is the circuits inside, the fact that there's a little laser beam which you can point at various different things, the way the circuits are constructed. The mechanical engineering, second step, is how things are made. So that would include plastic, the fact that the different colors are placed on top of it, the different materials, the fact that you've got a rechargeable battery in here that has to be next to the laser, temperature considerations. And industrial design is how things look and feel. So this is a little bit old-fashioned, but industrial design is what commonly people consider as being the prettiness of an object. As they often said, I think, about the first iPhone, is the iPhone is lickable. That's how pretty it is. And that stuff usually refers to the aesthetics. So when you make things real, when you're working on a piece of hardware, for me personally, it's quite exciting because you're touching things with your hands, and it's very different to touching a flat screen and moving things around in a virtual space. But as I said, there's also plenty more ways to die. Ironically, apps are kind of easy because at the end of the day, the phone's already built. You don't have to worry about the screen itself and whether or not people know that they have to touch it. They already know that. They've already built the phone. They've already built the way in which this thing interacts with the world. You just got to layer on top of it. So I'm going to go through a cycle really quickly of an idea process for a new idea that I had that I'm in the process of developing, and we'll see how this all fits together and see if there's any interesting lessons to learn from that. This is my bike. It's an Aprilia SR50 Ditec. It's a 50cc scooter. I know it's a bit unusual to have a grown man riding around on a scooter, but I love it, and it's super fuel efficient. It's the fastest production scooter in the world. So it broke, and it really annoyed me. And because it broke, but I liked riding around on two wheels, I decided to get one of these, because it wasn't very expensive and because I didn't live very far from my office. So I thought, oh, that's cool. Actually, this is not the exact bike that I got, but I couldn't find a nice picture of the exact bike, so there you go. The key point here is that this bike is lacking one very important thing. And no, it's not a brake, because it has a brake. You just have what's called a torpedo brake in Croatia, or a coaster brake in English. You push your feet backwards and the bike stops. It doesn't have any lights. So I live in Venice Beach in Los Angeles right now. I was born and raised in Croatia. And I ride the bike a lot to work, and as many startup people are, I spend half my life in the office, if not more. So I often ride it back from the office at night. So the office is very brightly lit, as is the sidewalk next to the office, but the alleys nearby are not. So what would frequently happen to me is that I'd be riding around in the dark and I go, this is probably not all that safe with cars around. So I borrowed from a guy in the office a bike light. The bike light that I borrowed looks a little bit like this. There's not many of you here, so you can see it. It attaches, this simulates a piece of bike handlebars. This is a light over here. You may have seen these lights. They're incredibly cheap. They cost $20 for a pair in the US. They cost about $1, including shipping, if you buy them directly from China. So you can imagine, however cheap the shipping is, $1 minus the shipping, minus that thing's got to cost maybe 2 cents to make. It attaches to the bike handlebar in a really easy way, rubber band, plastic hook. There's nothing to it. It has a small battery inside it and an LED. So what I had to start with is I had this bike and I had these lights on it. So what annoyed me about this? What annoyed me is, remember, the office is brightly lit, so I come out of the office and the lights aren't on. Very similar to how when you're driving your car and you're in a very, very brightly lit parking lot, sometimes at night you forget to turn your lights on immediately because you don't see that it's dark. So I turn into the alley, it would be dark, and I'd go, God, this is annoying. So I turn the front light on with my thumb, because my thumb is right next to the light, but I can't do that for the back light. So what do? I stop, I get off the bike, kind of fumble around, and I don't know where the switch is. It's dark, because of course that's why I'm turning the light on, because it's dark. So finally I do that. I get home, I got to do the same thing again. I got to turn everything off. So after doing this for 2 or 3 days, I thought, this is bullshit. Why don't these lights turn on automatically? Now when you turn your lights on your car, you flip the switch, all the lights come on. You don't go on, 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 on. Nobody does that. No one ever thinks to do that, because you just learn that everything is connected. So I decided that I'm going to connect, the white light represents the front light, the red light represents the rear. I'm going to connect the lights in a wireless fashion. And that's exactly what I decided that would be an interesting idea. The question is, how do you do that? Because when you have this kind of idea on a piece of software, you go, well, if you code, then you just write out the code, and it's a fairly simple thing to do. If you don't code, if you're more of a product or project manager guy, then you find a guy that does code, and you write together a really quick spec, and you go, hey, can you connect A to B and make it so that when button A gets pushed, B flips up, etc., etc. You write a quick spec, and a few days later, or in something simple like this, a few minutes later, you hopefully have a piece of code that you can prototype and test. So how do you do the same thing with a piece of hardware? Well, you basically have to improvise. So what I did was I took a very cheap, it's inside here, it's a tiny circuit, you can't really see it, but it's the same thing that you see on there. It's a garage door transmitter and receiver. It's used for remotes where you push the button in your car and the garage door opens and closes. It cost about $20 to buy for a set, and I hand soldered it into the lights. So that it meant there was one hand soldered into the receiver and one hand soldered into the transmitter. When you push the button on the light, both lights come on. When you push the button again, both lights flash, and when you push it again, both lights turn off. So as far as I was concerned, that idea was, oh cool, I made something, that's funny, keep going. I didn't think it was a product. So I just thought it was kind of cute and cool. I showed it to a friend of mine who happens to ride a bike a lot, and he said, can you make one for me? And I thought, I don't really feel like making one for you. I just made it for me. What are you talking about? That takes time. But he said, no, I really need one. And the reason he said he really needed one is because he has 4 lights. He's got one on the handlebars that points forwards, and he has one on his helmet, he has one on his backpack, there's another one under a seat. So to him, this problem is even worse, because it's on, off, off, and every time you ride, you've got to do that. So I thought, maybe there's something to this. And, oops, too far ahead. So as a test, I walked into a shop with this prototype, this very one. This is the first one that I ever made, with like wires hanging out of it, like you can see on the photo. And this was my market test. So just like you could normally do with an app, when you ask your friends, hey, can you install this? And then you go, what? That button that says next, he doesn't realize is a button? What's wrong with him? And you realize that some of your assumptions don't work. In this case, I was very lucky, because the guy in the shop tried the light, and he goes, yeah, I want 500 of these right now. And I thought, oh shit, there's something here. Maybe we can do something with this. Maybe it's an interesting idea. But again, this is kind of ugly. Remember the whole idea of mechanical engineering, electrical engineering, industrial design? Well, this doesn't have any industrial design. It looks like a piece of crap, because it kind of is. But, so is this a prototype? Is this an MVP? I don't think so. Not for a piece of hardware. I think you have to go much further. Clearly, this is a proof of concept that the idea works, but you've got to go further in order to be able to show this to people and say, here's a product that you can sell. So what's the next thing? One of the problems with electronics in general, I'm not going to dwell on this too much. This happens to be the actual circuit. I didn't want to show it in too much detail because there's a couple of things in there that are a little unusual, even though they look standard. The basic idea is, this is an Internet of Things problem. Does anyone in the room do any Internet of Things hardware stuff, or no? In really, really short summary, almost all of us have used short-range wireless devices on a regular basis, whether it's headsets, Bluetooth headsets for mobile phones, or whether it's remotes to open your car. So when you're using a Bluetooth headset, pretend for a moment this is a headset, this is your phone. This is actually a phone. This is not a headset. When you have 2 devices like this, the small device, which has a really, really small, crappy battery, is talking to the big device, which has an asymmetrically larger battery. So this device is pinging every now and again, but this device is always listening. But it doesn't matter that this device is always listening, because the battery is so big, you expect it to die and recharge every day. Just like in a car, when your remote control that unlocks your car sends a signal to the car is always listening. The reason it's always listening is it has a giant battery, so it doesn't matter if the battery decreases a little bit every time when it's listening. Problem with 2 tiny devices is the device that's listening is the one that will die, because it's going to use up battery all the time. The transmitter device, that's not going to do anything. 3 or 4 times a day, when you turn the lights on and off, that's when it transmits a signal. Otherwise, it doesn't do anything at all. Unless, of course, it's on, but that's a different problem. If you leave your lights on, the battery will die. So optimizing the receiver is a very, very serious Internet of Things problem that most people haven't bothered to solve. And the reason they haven't bothered to solve it is because they haven't needed to. Because, like I said, the device is usually operated in an environment where the receiver has lots of power. So we had to do that. That's a key step. But then we ran into this industrial design thing, and I wanted to really quickly show you how quickly this evolves. And this is, I'll repeat this in the conclusion, but in the same way that software guys use APIs and SDKs, for example, you don't have to build, if your application idea involves sending an SMS to your friends, or or users allowed to send SMSs to their friends, you don't have to build an SMS service anymore. You just go grab Twilio, or one of the multiple application software as a services out there. For very little money, you can integrate an SDK, and with one line of code, you can send an SMS. So how do you do that with 3D design? You can't do it quite the same way, except you sort of can, because people become your API. So you can go on Elance and find an industrial designer. If you go to somewhere in the United States and you find a celebrated industrial designer, they're going to cost you a few $100s an hour, which is probably outside of the price range of somebody trying to build a prototype. If you go to Eastern Europe, you can find someone who costs $15 an hour, possibly even less. The problem is they may not be very good. So it's interesting to think about how you end up using them as your hands, which is exactly what I did. So when I first gave the specification of what I wanted aesthetically to this particular designer, we ended up with something that looked like this, which frankly, I mean, I don't know if anyone else would buy it, but I wouldn't, because it looks sort of horrible and weird. So through an iterative process, which I won't go into in too much detail, I'll show you how that evolved. Lots of feedback meant that we started to streamline the process and figure out how it would attach to the bike. Then, for some reason, we had a Spider-Man phase. The Spider-Man phase wasn't particularly fun, but it got us into the right shape. We wanted to streamline everything to be smooth. So we simplified it even further. We started thinking about how it would attach to the bike. And then ultimately, we ended up in about 9 solid iterations, we ended up with something that we thought looked like it was just about there. Obviously, between this and this, by the way, is not the actual product. This is a photorealistic 3D rendering. But it gives you an idea of how we wanted the thing to feel and taste. I'm deliberately using adjectives that are not usually applied to products because that's the mentality that I approached when I was trying to design this. So, that's industrial design, and that's how an idea of how I simplify things. By the way, how are we doing for time? I've lost track of things. Okay. So what is left? So 3D printing. One of the things that's interesting is when you're doing things for software, when you want to test something out, well, it's fairly straightforward. You push build, and then you test it out in your ID, your integrated development environment, if you're a coder. If you're not a coder, if you're a product guy, you install it on your phone, and then you play with it, or you maybe use some sort of pre-visualization, a sketch, who knows? You can use a bunch of different tools. You can sometimes use paper and just flip through slides and figure out how flow might work. When you're building a product, you can't do that. When you're building a product, you actually have to touch it. So, for example, there are various different types of 3D printers that you can use. This is one of these lights that's, well, this is just the shell for the light. It's not the light itself, which comes from a very cheap 3D printer, which just extrudes from thin pieces of plastic. Many of you have seen this. It melts it into place and creates this design. It's annoying. It's hard. It doesn't really feel like the actual product would feel, but it gives you an idea of shape and whether or not it looks absurd. If you're just trying to understand basic curves, you can do that. They're very cheap. The printers cost about $1,000. These prints themselves, people sell them for $5 or $6, or maybe a little bit more. It depends on what the deals end up like. This, which is what you're seeing a photo of, this doesn't make, well, kind of makes the same noise. I was hoping it would bounce. It's made of rubber. I don't know if you can see, but it squeezes. So this is a much more sophisticated, higher resolution 3D printer. The printer costs about $300,000, and they sell the prints for about $40 to $50 each. They have a minimum run of a certain volume. But when you start doing stuff like this, suddenly you're like, okay, I kind of get this. I see what it would feel like. I see what it would look like. So it's an interesting process. Again, another example of how certain aspects of the process are similar for hardware. Where did I put the remote? There it is. Certain aspects are not. What do we got next? Oh, yes, mechanical. So unfortunately, I can't show you any pictures here, but I'm trying to think. You know what? I'll show you a quick demo. I don't really like to show this to people because the patent isn't filed yet. But so remember how we had this rubber band, which it's kind of annoying, right? Because when you want to put this on a handlebar, you're putting a closed object on a solid bar. You can't slide it from the side because there's not enough room. So to put this on here, you actually have to open it. So when you open it, you then need 2 hands because you need one to hold it in place, another hand to close it. Doesn't matter if it's Velcro or clip or a quick release system. Frankly, I find that kind of annoying. I like things to be one-handed because I'm intellectually lazy. That doesn't mean I don't like doing things, I just like optimizing things. So my idea for this looks like this. You take this device, you put it on the handlebar and it closes. The end, one hand. So this is ugly, and it's deliberately ugly because it's not polished yet, but you get the basic idea. So using magnets and rubber in an interesting way, you can do some new things. But again, where does this idea come from? How do you do this? You got to build it with your hands. You can improvise these things. If you don't, there are some people who build software who will never want to do things like this. But I grew up playing with Lego. I grew up playing with things. I grew up doing things with wood. I still like to do stuff like that. So there's something that's very tactile and magical for me about hardware that I don't get out of software, which I really enjoy. This didn't quite fit, but it's okay. So last thing is, don't forget that even though we talked about the various different steps in coming up with an MVP, you can't skip on, from my point of view, you can't skip on brands and names and logos. That stuff will haunt you down the line if you don't look at it correctly, which means that on top of everything else that you have to do with hardware, on top of the electrical engineering, the mechanical engineering, and the industrial design, you've got to think about graphics. So the reason this is called Blinq is because the B stands for Bluetooth and the link stands for the fact that it's a link between lights. The reason it's a Q is because kind of wanted to sound techie, plus Blinq, surprisingly enough, wasn't available as a domain name, whereas blinklight.com was. So you may notice if you're spatially oriented, this is an ambigram, which means that it looks exactly the same if you rotate it by 180 degrees. That was actually a very happy accident. We originally had it written as Blinq in normal writing. Actually on this light you can't see it because it's too far away, but it's exactly like that. And by accident it happened to be upside down on the table. And I thought, wait a second. The B and the Q are almost a perfect match. Let's figure out a way to make that work. So again, how do you do that? This is improvised entrepreneur territory. I don't know how many of you have read a book called Da Vinci Code. It was made into a movie with Tom Hanks. The guy who wrote it was Dan Brown. It's not a particularly great book, but it's a fun read. The plot centers around ambigrams and the Illuminati. So I remembered this. I read this a number of years ago, and I Googled the name. Say again? Yeah, but Da Vinci Code was the first one. Angels and Demons was the sequel. But yes. Oh, is it? Oh, I'm sorry. Okay, there you go. I remembered it wrong, but kind of. So ambigrams are in this book. So I Google who did these ambigrams. Find out it's a guy named John Langdon. So I'm like, John Langdon. Find this guy. He does ambigrams. He's a professor of fonts, and he does ambigrams. That's his specialty. So I go, hey, listen, do you want to do this thing for me? And he goes, oh, yeah, no problem. Yeah, it's $15,000 for commercial work. And I'm like, oh, shit. So I go, how do I do that? So I go, I tell you what, I'm going to do a Kickstarter. How about I give you a small percentage of the Kickstarter, the amount that we raise initially? And so I don't, embarrass him in case somebody tweets about it. I'm not going to say how much it was, but it wasn't very much. But here's the beauty of a deal like, he said yes, by the way, and he did this. So the beauty of a deal like that is that, what are you giving away? A small percentage of not much, right? Because there's no equity here. The deal is, sure, he gets some cash and he gets a little bit more if we're successful, obviously, because if the campaign is successful, he'll end up with more than he would have done originally. So he takes a bit of a risk. But it's interesting because even when the beauty of Kickstarter is not only are you basically selling nothing because you don't have the product yet, but if you're able to convince people, same as you would when you're pitching your idea to a room of investors, because everybody's your investor. If you're able to convince people like this, professional resources, you can give them a percentage of nothing and they will do work for you. So that's a key point to remember actually for any startup, but in this particular case for hardware. So in conclusion, just in case somebody has questions, I'll just speed this up, the last slide. Yes, it is possible to have a software approach to hardware. The same skills that you have, the same processes that you used with a bit of tweaking, you can use when you're making hardware. However, be prepared to unlearn some things you used to. For example, I automatically found that I thought about layout and user interface a little bit too much, and I did not think about the mechanical issues involved. How would you build this? You could draw something, but you might not be able to manufacture it efficiently, because if you for example, if this thing was completely solid because it looked awesome when it was solid and had no curves whatsoever, how would you put the batteries in? Because eventually the batteries would die. So at a minimum, you have to have some method of taking the batteries in and out. So it's the kind of thing that bothered me because I didn't internalize this because it was the first time I did it. Think of people as a software stack. The same way that you would use services like Twilio when you're making software, you can use people that way. You don't have to have experts that do everything nowadays. Just like you don't have to have a stack that does everything, but you can combine different stacks to do different things that your application might need. You can use people the exact same way. And they're more than willing to do it, because if they have, the more specialist the skill set, the less expensive the resource. If you're able to, as a software product guy, mix and match different resources, you don't have to hire a full stack developer if you don't need it. Same thing here is I was able to use a low cost resource to create what I consider a good product because I'm sitting on top of it, guiding it in some way. I'm basically making myself smarter by using people, just like you can make your code smarter by using stacks. Elan says, your friend, get your hands dirty. Play with wood and clay and Sugru. If you've never seen Sugru before, Sugru is an invention of I forget what her name is. She's a female inventor based in Ireland. It's a piece of rubber that cures when it's exposed to air, and it cures in about 24 hours. So when you take it out, it feels like a plasticine, or plastiline, I think they call it in Croatia. But in about 24 hours, it becomes solid, but not completely solid. It becomes solid rubber. So it's the first commercially available curable rubber, and it's phenomenal, actually, for various different things. If your iPhone cable breaks, you just use Sugru to patch up the cable, and it's still flexible, but it no longer has exposed wires. So yeah, I'm more than happy to throw up her URL, because I use it all the time. Ask for advice. Hardware geeks are exactly that, and most people ignore them because they're kind of weird and have long hair and sit in the corner and play with wires. If you talk to them, they usually will offer their advice, often freely. Recognize which bits you can't do alone, outsource those, well, we know that. And then the last bit I talked about a little bit, which is trade Kickstarter percentage for work. You'd be surprised, that's not the only one I did that way. But there's one, the guy who helped me out with designing aspects of the circuit, same thing. He's a guy that I found online who was a university researcher, as it happens in northern China, in a small obscure university. And I liked him. We sort of corresponded quite a bit, and he ended up getting involved. So I think that's kind of wraps things up nicely. Does anyone have any questions, or no?
Yeah, over there.
Okay.
No, it's cool.
You can scream if you like. Oops, what did I just do?
So this became your side project, or how much time are you actually spending doing Blinq comparing to your normal
it's a very
job? Because it seems that you're pretty involved in that.
Sorry, what was the last bit? It seems that
you're pretty involved in the whole idea. So how much time did you actually spend on working through that?
It's a very interesting question. It is a side project. Whether it in the next few months becomes more than a side project remains to be seen. When I tell you the story like this, it feels like, because I'm passionate about it, it feels like I'm super involved in it. But one of the jokes that Keith was making at the beginning about marketing is, if I was telling you the story about one of Keith's companies, it would sound as though I'm super involved in it, because I tend to get excited about stuff that I'm talking about. I'm not trying to deny the fact that I was involved quite a lot, but it doesn't take a huge amount of time, because, I mean, I think, let's say, it's been a total of 3 months, and in those 3 months it's been maybe, you know, a couple of hours on the weekends, and obviously answering emails and communicating with touch points during the weekdays. But for example, when we were going through this entire cycle of designs, believe it or not, that was, in terms of his time, the amount of hours of design time that was paid for was something like 15 hours. So most of that was, he would spend an hour and a half, he would bring back a set of prototypes, and I'd go, oh, no, this, no this, no that. In other words, I would give him 5 minutes of feedback, and he would go off and do it again. 5 minutes of feedback, go off and do it again. So in that, I'm sorry to take so long to answer the question, but it intrigues me. The actual amount of time of work is very small. The actual amount of time of distraction is very large. So that's where it gets a little tricky when you do these side projects. This whole Google 20% time thing, yeah, it's lovely in theory, but if you're the CEO and you're doing that stuff, it gets a little tricky to manage your interests. Frankly, for me, if I don't have side projects, I get unhappy, because I find that I like to satisfy my creative urges in various different ways, so I like doing multiple things at once. I don't know if that helps or not.
Any other questions over here?
Thanks for the presentation. It was really great. So I'm into software. So I was really curious how these things work. And well, one of the huge differences between the software and like the physical objects is that when you create a prototype of the software, you can immediately give it to, let's say, 1 million users. So you can just make copies and the copies of that. Mm-hmm. And for the products, you on some point you will actually have to produce it in some way. Are you already on the stage where you're thinking about what happens after you have like this prototype and it's great, but now you have to like create thousands of copies of that? You probably need a factory or something.
Yes, you're right. I mean, this presentation was cut short. The next part of the cycle is once you have what you consider a production-ready prototype, let's pretend for the moment it's what we're looking at with this slide. You then need to establish relationships with factories. There are multiple different ways you can do that. You can use a, shall we say, local factory. For example, if you're in Poland, I'm sure there's plenty of them. Likewise in Croatia and in the US. The problem is local factories for hardware are unfortunately very expensive. When I say very expensive, they're about 10 times more than it would cost you to make the items in China. The problem with making it in China is you go to any factory in China, you ask for 100,000 units, they'll make 300,000 and 200 go out the back door. And I'm not saying that as a diss on China, that's just what they do. It's quite known that that's how their hardware processes work. Unless you're Apple. If you're Apple, then yeah, you can protect against that, but it's very expensive. So yes, you do need to find a factory to do your full production run. Before you commit to the full production run of 10,000, 50,000, however many, there are multiple different production prototype cycles that are much more expensive and sophisticated than the little things that I did. They'll do a prototype that actually has the electronics in it. That starts to get a bit expensive, but it's not awful because you're not doing molds yet. When you start doing molds to stamp out tens of thousands, that's when you're looking at minimum $50,000. But prior to that, for $3,000 or $4,000, you start to do super sophisticated prototypes and go from there. But the question you asked, which is how do you get people to try it, it is much harder. It is much harder to dog food hardware because you don't get a chance you can't release it to thousands of beta users. There's no test flight for hardware, unfortunately. It's not called that anymore, is it? Because since Apple bought it, I still call it test flight. Test flight is a beta testing system for iPhone apps. It is? Thanks. That's right, yeah. But one of the things is there's a lot of, for my sins, I have the ego of product guys, which is that I like to think that I know what the product is supposed to look like. I know that's considered a terminal sin when you're designing product, is you're not supposed to just use yourself as an example. Well, no matter how many times people tell me that, I still do that, and I'm sure that plenty of other people in the room do also. So you are right, that is a problem. It's harder to test than software on the general audience. However, there's something that, I don't know, something happens when I touch objects and I very quickly just go, okay, I like this or I don't like it. Not everybody will feel the same way. Some people will feel more comfortable looking at the wisdom of crowds. In my case, I'm very happy dealing with my own feedback to a much bigger degree than perhaps I should. But
we've got time for one quick question to wrap up. Anyone else? No? Okay, so Nick Bicanic, thank you very much.
Thank you very much, guys. Thanks a lot.